So the general strategy with these types of questions is to look for standard identities, and also to combine like terms and see what it simplifies to. So the first thing I'll do is to expand that, and then I'll move these terms to one side. So x squared plus 4yx plus 4y squared. I'm leaving this for a moment because I see the x minus 2y here. So we'll see if we need to expand. But generally, I prefer not to go in that direction because this will be additional work. And as soon as you move these terms here, you immediately notice that this is a perfect square. This is a square of x plus 2y squared because you have x squared term, and then this is 2y squared, and then that is twice their product, x and 2y. So that means that becomes a perfect square. That one is already a square. And now we end up with this scenario where you have two squares that you're adding and it has to be equal to 0. Now note that anytime you're squaring a term, it has to be greater than or equal to 0. And because these two have to add up to 0, that means the only way this equation would hold true is when each of these individual pieces are equal to 0. And this type of a setup is I've seen in several problems now on the CAT. So just kind of keep in mind that this is one of the variation you will see. So we have these two conditions, and the second one actually gives me that, and this is what I'm looking for, x minus 2y, which is answer choice A. So this part, you don't have to do anything with it. I mean, if they asked you to compute, I mean, those would be other variations. X is minus 2y, and if we plug that in here, we would be able to find what y is. And it's possible that in other questions they may ask you, what is x plus 3y or some other variation. But in that case, you'll have to find out what x and y are, which we can individually. But for this particular question, we don't have to do any of that, but be open to those variations. So in summary, the answer is A.